Good morning. Well, first we do a short round of introductions. As I said, I'm Maurizio Pilu from the Catapult. I'm Partnerships Director here. And could you say who you are and, in 30 seconds what you do?
Yeah, I'll do it less. I'm Stuart Revell. I'm CTO of TechUK. I have a presentation, so I'll cover the other aspects in the presentation.
And I'm Martin Hamilton, Futurist at Jisc, and I also have a few slides. So we'll say a little bit more about what that means.
I'm Geoff Varrall from RTT. We're RF technology specialists, and I'm a past director of Cambridge Wireless and helped to organise some of the Cambridge Wireless events.
Thank you very much. So before we dive into the topic of the session, which is the application perspective of 5G, I wanted to hear your reactions to Rahim's presentation, and perhaps one way of starting with that is a short thought from you about what you think 5G is, because there are many definitions of what 5G could be. I mean, some of it is about speed, some of it is about seamless connectivity, but what is your perspective?
Do you want me to start?
Yeah, go for it.
So maybe we cover it in the slides, but...
Yeah, but go for it.
I mean, the title of my short 5-minute presentation is Sufficient Bandwidth, Seamless Connectivity in Any Context. And I think what Rahim presented there was actually very good, because a lot of 5G events that I attend, they tend to look like an evolution from 1G, 2G, 3G, 4G to 5G. And Rahim touched on everything in terms of Internet of Things, big data, looking at crossing industries from energy, utility, healthcare, and I think that's an incredibly important difference between what I'd call the traditional evolution from 1G to 4G and 4G to 5G.
Thank you, Stuart. Martin?
I think we've talked about the innovation, and that's all brilliant, but there's also a sense in which it's an insurance policy. So we've seen huge growth in terms of demand for data services. If we don't have our insurance policy, then we stand to get into serious trouble a few years down the line. So the innovation is absolutely wonderful, but actually let's not lose sight of the insurance policy.
Future-proofing.
Absolutely.
Geoff?
Well, I see 5G as an innovation platform, and that's technical and commercial innovation. And in order to be focused, you've got to work out what problem you're trying to solve. And I would say probably the biggest problem to solve is cost. And that's driven by looking at the industry today, and you look at the EBITDA of operators around the world, globally, thinking not the UK one. Even in America, which has had one of the highest EBITDAs, with one of the highest ARPUs as well, you've seen EBITDA going down over the last 2 quarters for AT&T and Verizon. It's a very significant change. So really, the only way of solving the cost issue going forward is when you look at all the spectacular projections of data volume growth, they have to be predicated on a step function, or probably several step function reductions in terms of delivery cost per user bit. And that's a combination of CapEx and OpEx delivery cost per user bit. So I would define that as the biggest single problem to solve, without which we do not have a 5G proposition. And possibly the interesting areas to look in terms of innovation are commercial innovation, are what I describe as the mutual interest models. And there are some examples of mutual interest models working. Satellite industry is one. Satellite industry, if you look at the satellite operators that are investing in Ka-band at the moment, people like Inmarsat, Avanti, their whole business proposition is actually based on a combination of civilian and military payload. Defence income is very important to them. And the defence sector is producing innovations in the RF-dependent space which are directly useful to 5G. So there's a mutual interest model developing actually in the satellite industry between military and civilian, which I think is very relevant to our own interest.
Thank you. That's interesting. So we have a cost, we have future proofing, and we have like an application side of 5G. And I guess they're not mutually exclusive. I think it's all of them. And that's actually what we're going to discuss now. Now, you are all going to give your perspective on the application side of 5G. I think you have a presentation, you have slides, and you're going to just chat about it. So, like 5 minutes each on that. One of the important things is that you try to cover applications that are enabled by 5G versus what can be done now. I know it's going to be quite gradual and it's going to blend naturally into 5G, but it's quite important to see what 5G could enable that cannot be done today. And I hope you can cover that in the slides. If not, we'll cover that later in the discussion. So I'm not sure what is the order, Alex. Is it Stuart first?
I'm not sure, but we'll find out.
We'll find out.
No, it's Geoff who said
Geoff.
he wasn't presenting.
Don't worry about my presentation.
Right, so we
too
start
long.
with Geoff.
No, he said don't worry about it.
No, just go to the end. That's fine.
You sure, Geoff?
Yeah.
Well, it's up to you. You can.
No. I can chat through this.
Looks great to me.
Yeah, fantastic.
Then you know what we do? We just put the holding slide. Yeah, that's right. So, Geoff?
What's that? Oh, am I
hopefully.
starting?
Yeah.
Okay. Well, no, forget about the slides. So, just to carry on where I stopped, really. So let's look at technical and commercial innovation in the 5G space and what are the problems we've got to solve and how are they being solved in other parts of the sector. I mean, my starting point also is to look at who's got the money to spend on this stuff. And of course, we look at the telecoms industry and, well, what's the budget at the moment for R&D? It's about $1.7 trillion, something like that, worldwide. And that equates to about 3 or 4% of GDP in some markets, the US being an example. If you look at, if you agree with the predication that cost is a problem to solve, then one way to solve it is to say, well, who else can spend money on this stuff? And the starting point there is say, well, what other communities have similar spending power? Well, the defence community, for a start. So the defence global research budget is about $1.7 trillion, actually. So it's almost identical to the telecom spend. And to me, the interesting thing about the defence industry is that, 40% of that is the US. So the US defence spending is around about $670 billion per year at the moment. That an increasing percentage of that defence budget is being spent on RF-dependent devices and RF-dependent systems. Now that includes mobile comms, it includes munitions, smart munitions, it includes aerial vehicles, unmanned aerial vehicles, drones to you and me, and it includes LEO, MEO and GSO satellites, both military dedicated satellites and co-investment with civilian platforms like Inmarsat and Avanti. So that strikes me as quite interesting, is to see from a 5G perspective, are there lessons to be learnt from 4G? And I would say yes, and actually they're quite positive lessons. One of the issues about defence is that they're everywhere. I mean, in terms of, we assume that a lot of the defence spectrum is going to be up for grabs, and that some of the spectral requirements that mobile broadband is going to have over the next 20 to 30 years can be serviced by transitioning defence bandwidth, L-band, S-band, C-band, all the K-bands, E-band, into the mobile broadband segment. Well, possibly, but of course, all the investment that is going into military systems is requiring more bandwidth. If you look at radar, now radar is everywhere from VHF to UHF, S-band, all the way up. You've got new systems coming in that have megawatt transmit powers, and they require very low receiver front-end noise. So when you look at the defence industry, it is becoming more and more sensitive to interference, basically. And the issue of spectral encroachment is one that is very robustly argued in the States and in other nations. So you have to consider where the defence industry is going. Now, you either have a battle on your hands. So, for instance, one thing we've learned with 4G is that we're not getting on with the broadcasters very well. Okay, so the US, again, is the model where you've got the 600 megahertz incentive auction that's running into all sorts of problems pre the election in the States. And you think, well, yeah, the difficulty with that is, of course, that the FCC has set up an adversarial auction process. So as soon as you've got an adversarial auction process in place, then, of course, it frustrates any attempt to get some kind of working together with the broadcast community, which has created a number of problems. With the defence community, it potentially is different. And the reason it's different is that the defence community, generally worldwide, is very interested in LTE. And the reason for that is that there's a lot of good LTE hardware in the 700 megahertz band and the 1800 megahertz band, both of which are traditionally good hunting grounds for military communications defence systems. So it makes sense to do a transition from if you're going to your next generation mobile comm system in the defence sphere to have LTE hardware as an important part of your offer. And you see LTE military modems going down the same production lines as you've got LTE consumer modems. So you do have an evolving model there of LTE working with the defence community, and I think that might be an area of interest for 5G, is to say, well, looking forward over the next, as Raheem says, to 2040, where are the defence budgets going to be spent, and where is the mutual interest model that allows us to use parts of the defence spectrum in L-band, in S-band, in KU, K-band, K-band, and E-band, such that we aren't actually short of spectrum, that we've got sort of co-use models that work, that we can take forward. And the final point I'd just make is that in the military domain, there are some really interesting innovations coming through in areas like digital CMOS, which is really important to us. You know, if we're going to start operating at 60 gigahertz and we don't want amplifiers that are 8% efficient, then we've got to do something about it. If we're going to work in E-band, the FCC have licensed E-band, which is 70, 80, and 90 gigahertz. Those are 5 gigahertz bandwidth systems, and you're allowed to use 3 watts. Really interesting. But you can only do that with digital CMOS that actually gets you some efficiency and in those sort of bands. So some of the work that DARPA is doing in that area is really interesting. Some of the work that DARPA is doing in terms of satellite technology is really interesting, especially on-orbit servicing of geostationary. It will completely transform the delivery economics of the geostationary satellite industry. Really important for the Middle Earth, you know, all the equatorial stuff. So I think that's interesting. And the last one, I'll shut up then, is timing. And in fact, Raheem mentioned about this, is the importance of accurate time domain distribution in any network. That's whether you're running, you know, trust systems or whether you're running, you know, latency type networks. And DARPA's doing some really interesting work in how you distribute clock accuracy.
Thank you very much. And the key message here is to look at defense as a potential application space. One interesting. And I'm sure there will be lots of questions around that. I have to admit that I don't know the order of the slides, so we have
it's me now.
It's going to be you. Okay,
yeah,
fantastic.
it's all queued up, Maurizio.
So Martin, you can start at the
I'm okay sitting, actually. So what I'll do, I'll skip through these, so in the interest of time. But there are a couple of things I wanted to draw people's attention to. So we're the folk behind the Janet network, and we heard a little bit from Raheem earlier on about how the Janet network interconnects universities and colleges. We're increasingly looking to see how we can make the Janet network useful to industry as well. So not just big businesses, also to SMEs. And we have a scheme going. If anybody wants to talk to me about that, come and find me. And that agenda has really been the thing that's brought us to talk to the Catapult. So we've had some very good discussions, particularly with the Digital Catapult. And I'm one of the judges for the showcase stuff that you see outside. So if you like it, thank me. If you don't like any of the stuff, do let me know. But we're actually quite a big market in ourselves. In research and education, it's nearly a £30 billion a year business. We tend to turn a blind eye to that, but actually it's huge. And within that, our Janet network actually is quite a big deal. So we're running right now at 3 terabits, and we have a roadmap to go beyond that up to 5, 8, maybe 10 terabits. And what that means in practice is we're dropping 100 gigabit links in places now. So when we talk about what could we do to accelerate industrial innovation, that very much is a conversation. How can we make the kind of testbed networks that go beyond a single campus, let's say? Well, we think that we have a good asset here that we can leverage. So I'll skip around a little bit, but I think the concept of what does 5G mean, it's quite nice when you go around and you see what different people have to say about it. So the combination of low latency, high bandwidth, and actually at speed as well. So it's very interesting when you look at what the industry has to say about this. These are actually hugely challenging goals, and obviously, as Raheem has observed, we don't quite know yet what the bag of technologies will be that will enable us to achieve those goals. I quite like the Metis description, which is rather more general and probably easier to achieve. So we're not aiming for particular numbers here. We're aiming for a step change in terms of capability. But I also liked this thing, which I've stolen from Huawei. So Huawei's kind of 3 axes of 5G, I think, is a very useful model. That's not with permission, I hasten to add, so don't tweet that link. What it means for me, though, is we've got bandwidth, latency, and massification. So let's say on the one hand, bandwidth, well, I'm wanting to stream the new Despicable Me movie in 8K. 4K is so last year, 8K is where it's at. And obviously I'm doing this in a mobile way, but that's one extreme. And then the other extreme is sensors in all the street furniture. And right now we're only taking baby steps with so many of these things. So if you look at Thingful, one of the exhibits here, you'll see the map of Internet of Things devices, for example, in the Greater London area. There's quite a few of them. But you look at that and you realize that number will increase exponentially in the next few years. So similarly, latency, I might be wanting to do a little bit of gaming, whatever the Call of Duty title will be in 2020, 2030. I'm sat there on HS2. I actually want ping times that mean that I can collaborate or I can play games with the folk that I'm trying to do these things with, while I'm on a train that's running at 400 kilometers an hour, and that's actually a huge challenge. But these are things that we would actually know and recognize right now. I'm sure that there will be applications that we will look at in 10 years' time and we'll say, well, wow, I never saw that coming. But I think a huge amount of the 5G landscape will actually be things that we already know that we can take to a level that we can't currently. And then there will be things that are in the prototype stage right now. So I've got my cheesy example here of tracking your Amazon drone delivery. We probably don't need extreme latency requirements. We just kind of want to know it's in the general area. You might want to go and take a look to see if it's dropped your box outside your house. Different ball game entirely, but they will all use that common infrastructure. And I'm stealing your thunder here.
No, that's fine.
And finally, the concept that right now, if you take something like the FA Cup, well, Wembley Stadium has room for 90,000 people. Right now, only a tiny proportion of those people, in reality, are sat there going, well, I'm going to tweet a picture of this, I'm going to post a Vine video of this. But that is increasing and increasing faster than anyone could possibly have imagined. And then the countervailing example is actually, I just want a telepresence session between 2 rooms. That's not 90,000 people. And this network has to accommodate all of those use cases. And my personal favorite is this guy here who's teaching students to do surgery using his Google Glass. And we can picture that will be the 8K streaming in a few years' time with realistic blood spurt. I like to trot this slide out because of the realistic blood. It's okay. It's probably only ketchup. And these things, we are starting to see them, and I think we could probably guess what a lot of these applications are going to be from the things that we're just starting to see right now. They're not mainstream. Some of them are quite experimental. Some of them are prototypes. And connected forks, connected contact lenses. When you squeeze a 5G modem in there, that could be a challenge. So maybe not all these things will be 5G. What I finally wanted to say a couple of words about is we realised we could leverage the asset of the Janet network, and subsequently we've had a lot of conversations with universities about equipment that they hold. So for example, that's a £1 million supercomputer which is now available to industry through an agreement that we brokered. And increasingly we're talking to universities and colleges about the capital-intensive equipment that, if made available to industry, could help accelerate innovation. So where it's something like modelling and simulation of antenna designs, ultimately I might actually build some prototypes of this thing. I want to model it 1,000 times on a computer before I build a single prototype. When I do build the prototype, I probably want to stick it in a wind tunnel. You know, I'm going to put this thing on a mast one day. I actually want to know what's going to happen when I stick it in the wind tunnel. There are some very effective collaborations that are already working there, but equally there is so much more that we can do. So we're very interested in that whole brokerage agenda. We've got a few partners already lined up behind this, and the supercomputing thing is the one that's really starting to make some traction now. So we've got £60 million worth of public funding in supercomputing that we're making available through a common agreement. So I think that there'll be a lot more of this, and that collaboration will be key to taking those applications from the prototype stage to, you know, that massification I was talking about. So that's me.
Thank you, Martin. I enjoyed the presentation.
Thank you very much.
So we are running slightly behind.
I knew you'd rush me.
No, I'm not actually. I wanted just to say that.
I will
just
stand up,
say
Maurizio.
that I picked up a couple of things from your presentation. One is continuity. So you're saying that there is a lot of stuff that is kind of being done now, but can be done much better with 5G. The other theme is what you covered at the end, which obviously being from Jisc, you will expect that, but it's actually an interesting point, which is UK industry and academia and research institutions should come together to aggregate these assets that can be useful for this agenda, which is also something that Rahim said earlier about spectrum aggregation and so forth. So this is a very, very good message, which I'd like to pick up later in the discussion, the short discussion we're going to have after Stuart. Over to Stuart, and I know you're going to be, I know, knowing you very well, I think you're going to be disruptive.
I won't be disruptive. I'm going to be challenged to try and do it in 5 minutes, but let's give it a go. So I mentioned already, seamless service with sufficient bandwidth in any context. So quick introduction, I'm the CTO of TechUK. I only joined TechUK on the 1st of September. Just a quick poll, who knows TechUK? Oh, that's good. That's excellent. Okay, so I won't go into details, but we have very many working groups, campaigns, councils, covering all aspects of the industry that we've been talking about this morning. And that's one of the reasons I joined TechUK. Again, I won't go into this matrix, but one of the challenges I've had in the first really few weeks was kind of worrying about putting things into boxes. You know, the certain council does this and the certain council does that. Actually, I'm trying to change that because I want to embrace overlap. And if you actually look there, you've got 3 layers: promoting technology and markets, government incentives, influencing policy and regulation, business and economics, research and development, enabling technologies and innovation. If we're going to make 5G work, we have to get those all working together and not singly developing a point technology without looking at the policy and regulation and the business models. And I think that's been touched a few times this morning. This chart I've been working on with government and industry actually before I joined TechUK over the last year, and really it's built around the information economy strategy. And if you look at the information economy strategy, if you can't be bothered to read the whole document, if you look at things like wireless technology, radio spectrum, 4G to 5G and beyond, optical, software-defined networks, virtualization, cloud, big data, Internet of Things, machine-to-machine comms, smart everything, that is the information economy strategy. You start overlaying health and social care, energy and utilities, transportation, consumer and content, and coming back to Maurizio's point, building services and applications sitting on top of this. This is the challenge that we're doing. It's not to say that we do need to develop that 5G interface, we do. But actually we need to look at this whole landscape. So technology and service innovation. TechUK, in partnership with WWRF, hosted a 5G huddle. Many of the people in this room either presented or attended that huddle. What struck me was that felt like, it was a very good event, I thought it was absolutely brilliant, but it felt like work when I was in Motorola and I was developing wireless solutions. It felt like a 3G meeting. And it was all about, you know, we need lower costs, we need to sort this latency out, we look at these coding schemes, all good stuff which we need to do. But actually, if you go back to that landscape, it's point solutions working in single networks, and they're kind of treating the whole world like a single network. Well, reality is, world's made up of many networks. Even Rahim answered and he said, which operators do you have? Well, we don't have 3. Well, actually, if you look at that landscape, there's a huge amount of operators. Energy operators, PMR operators, and if we're really going to connect them up, we need to think about how to do that. So we started writing this paper. Actually, this paper started as a KTN activity about 6 months ago. It's actually, nothing's written in it yet. We're still working on all the concepts and workshops. But we need to put a UK proposition together because actually the work that Rahim is doing in extending that reach is great, but there's so much more going on as well. And we need to collect that and leverage that in terms of all of the activities of 5G. So we do need to develop the photonics, we do need to develop the air interfaces and all of those technologies, and we need to be working internationally. But what struck me was the challenge is the same one, in fact, that Maurizio and I worked on the Internet of Things. It's this fabric. So I coined the term a 5G digital fabric. How do we bring all these things together? And this is really what I want to talk about. Now, the air interface diagram, I tried to look for my old ones, but they were confidential, so I couldn't publish them. But I had those diagrams 15 years ago, and they don't look any different. So we're trying to, you know, create a compromise across all of those diagrams, across all of the different services, across all of the different air interface. But what I would say is that diagram doesn't only sit on an air interface, it sits across networks. Geoff touched it, you know, latency issues, cost. Now, laws of physics say you can't do that. There are some people saying you can, and if they can, wonderful. But actually, laws of physics say you can't do that. So coming back to this 5G digital fabric concept, and the reason that we need this, we need to abstract that complexity of below of all of those technologies and networks so that people can actually do the service and application development from 5G. Now, if you take an app as an analogy, I remember sitting in meetings with mobile company suppliers, and the app and developer, well, not even, it was the developer world, will have a go at one company saying, I have to develop 6 different versions across your own portfolio, and that was one company, and then you extrapolated that out. Things never really started to take off until that complexity was abstracted. So we need to abstract that complexity. The thing that's so important about abstracting that complexity, the world is not made up of one network, so all the policy, control, billing, security, we've got this federated version that we have to cross. So coming back to the cost models, you know, when you go in that seamless context, throughout the day, in my 5G vision of a world, you may be connected to 10 networks. You don't want to know about any of those. Security, policy and control needs to be taken care of. And when you start looking at the applications around the outside, I've just put a few things there. Automotive, remote monitoring for maintenance of things, interactive media, location, payments, commercial, healthcare. If you really want to make a difference, connecting these up. This is a diagram that some of you may see present. I've used this diagram now for 2 years. I'll be presenting it at a healthcare conference on Monday morning. This is reality. The value in a healthcare system and those networks. Today, if I just take a hospital, they have more than one network in a hospital that doesn't talk to each other. If I take the user out of its context, private health, mobile, clubs, friends, families, social care, all of these are all disparate systems, not connected. So my vision is look at that fabric, because actually I think the UK is really good at doing complex projects and stuff. And that is where we could lead the world. I would say, coming back to this, I'll use this network diagram here. On the outside, you've got, on the left, sorry, you've got context, people and things, an analog world, rich with data and information. On the right, you've got big data, cloud and services. But in the middle, you've got this complex mix of all these different networks that somehow we need to fix that fabric so people can design things that work on both sides of that diagram. I think we've done a 5G demo already. I think London 2012 was a 5G demo. And if you think about London 2012, I met with the Tokyo 2020 team last week, an NTT, and I proposed to them that we should work with them to look at a 5G digital fabric type concept. If you look at London 2012, we had 8K running over the Janet. We had security, we had ticketing, we had managed spectrum, very closely managed spectrum to ensure that we had sufficient bandwidth in the venues. We had Twitter feeds, we had social media, we were monitoring all of those things. But do you know what we did? We couldn't automate it. So in Canary Wharf, in the Technology Operations Centre for LOCOG, we had 200 people, 3 shifts, so that's 600 people, 24 hours, taking all this manually and doing it. So the people were the fabric at that point. I think between now and 2012 and 2020, connecting that up and automating what we were doing manually is 5G. Except it is not the 5G MIMO, and so this is the fabric side of it. So I think we've got a huge opportunity. And there's just a very simple example. How do you get, for example, 5 networks in your context as a person or a thing to work together so you can build sustainable business models and services on top?
Thank you very much. Thank you very much, Stuart. Very powerful concept is digital fabric. I think your message was slightly different from what we heard.
Yes.
From the panelists, because you were looking at an enabling layer. So you said this has to be right to enable a lot of applications. If you get it right, then all sort of things can happen. And also, I picked up on your point that sectors such as energy or health should be somehow enabled in a TBD way, because it's not clear, enabled by 5G if we get the abstraction layer right. So you were almost arguing for the 5G specification to understand in relative depth what the sectors need.
I think my vision is more of next generation networks. I think 5G's got an excellent brand, and looking at some of the challenges of, the satellite community, working with an energy operator, working with, we can use 5G standardization perhaps to start looking at those interfaces, crossing these boundaries.
Interesting.
And then you can have that digital fabric. I firmly believe the ideas that we've got here, we've got so many subscale trials of healthcare, energy, all of these actual things, but when they start to cross boundaries and you start to do it with scale, it's not there. So we've got to get something where we rally round a concept, so maybe it's a 5G digital fabric, and then you get economies of scale. Then you start abstracting the complexities, so the service people and the app developers don't have to worry about the underlying complexity. Internet of Things, hypercat concept of discovery and everything like that. Wouldn't that be great if you had a security policy and control engine that you could discover and that could be portable and federated? For example, these are just ideas. By the way, people aren't doing that, as I'm aware of today.
Well, just picking up on another point, so in your view, is it better for the community to start from a sector, let's say transport or energy, in terms of developing a large-scale demonstrators, or be application agnostic, which is what Rahim is doing in Surrey at the moment?
I think you need a combination of two. My personal point of view is, I think if you do it to solve social economic challenges, so if you take energy, congested cities, transport, whatever you want to call it, and healthcare, we can lead the world there because we do have great point technologies, but if you actually address those interdependencies and challenges across borders, we're not doing it. I've hosted Chinese delegations, Japanese delegations, literally in the last few weeks, and when we start talking about that concept, just broadcast and mobile, Japan, they was amazed that we sit in the same room and talk about how do we solve those challenges, because they find it very difficult to do. So that creates an inward investment. Inward investment creates innovation opportunities. Janet, that's a great asset.
Yeah. I was in Brussels 2 weeks ago, and I was speaking to Bernard Barani. You know him very well. And he was talking about some discussions about enabling the next Olympics in Korea, I think, with 5G, which I found incredibly fascinating. That's an example of a demonstrator with an application in mind. Well, it's actually a set of applications, but a context, if you like, to try it out.
Actually, that point, out of the 5G huddle, what I clearly took away from me was 2015, 16 trials, 2018 South Korea Winter Olympics, 2020 Tokyo 2020 Olympic Games.
And we want something in London or the UK for sure, right, within that time frame. A question for Martin. Actually, not a question for Martin. On the point of continuity, I'd like to do a show of hands. How many of you believe that 5G is going to enable completely new applications that we haven't seen today? It's about 50%. So, it's an interesting debate whether 5G is going to be evolutionary from an application perspective or it's going to be disruptive. And, just a final comment from you before we do a couple of Q&As. Couple of questions.
So I'll throw a thing in. So here's my Motorola Smartwatch, which I got maybe a month ago. Actually, that technology started being developed in the 1980s, and it was only around Christmas time 2011 that the first watch-sized thing that you could identify as a smartwatch really became feasible, and that's through miniaturization. It's through essentially through all the technology that you have in your pocket with your phone being squished down into that form factor. So 2011, that thing which had been brewing for all those years finally became possible. And then subsequently, that's been the domain of the early adopter for, really three years. And only now are we starting to see that stuff come to mass market. And I think that there is I'm not quite sure how to describe it, perhaps a blinkering or a blinding that takes place if you live in that space, if you live in the leading edge, in the innovation space, then occasionally you go back out into the real world and you say, well, actually, hang on a minute. I'm the only person that's got one of these. I thought that was a product. I thought that was out there in the consumer marketplace, but actually it's only reached 1% or 0.5% of the actual market. So I think that there are a lot of things which are out there right now, if you know where to look, which most people will see as incredible new innovations.
Thank you. And one final question for Geoff. Military. I have to confess I know very little about that world, but do you think that the military sector will be using commercial communications technology in the future? It's a big question in my view.
Well, they already are, because if you invade a country in the Middle East, the first thing you can take out is the broadcasting. So you blow up the towers and you've got immediate LTE 700 bandwidth. So it's not it's a very convenient way of putting in an instant network at a cost base several orders of magnitude beneath what the military could deliver on their own. So no, I think the mutual interest model with LTE and the military is very strong, very established in the 700 megahertz band, the 1.8 gigahertz band. I think the challenge for 5G is just to translate that up the spectrum to all the K-bands and E-band. I think the other point why LTE is military friendly is that you can build very big cells. The physical layer is very appropriate for building supercells, large cells, which is pretty convenient if you want an instant network out there. And I think that's the other side of the coin, because a lot of the 5G discussion is about network densification. And to go back to my original cost point, one of the difficulties about network densification is it doesn't really solve your CapEx and OpEx problem. In fact, it makes it worse. So I think there is a counter-intuitive need within 5G to actually look at big macro cell capabilities. And again, just to finish the argument, the place you look is the satellite industry, because you've got 4 or 5 satellites. You're covering Central Asia, Africa, Indonesia, India, all in one hit. So when you look at what I describe as super sparse networks, then the satellite community is there, very effective. And of course, the way that they get the link budget up is by using smart antennas, basically. So if you're working at E-band and you've got a 1 degree beam width antenna, so you've basically got 1 degree beam widths you're sending out there and illuminating. You've got a 44, 45 dBi gain. Now, as soon as you start looking at those system gains and you start looking at a 3 watt transmit budget, You've got, even at E-band, 60 kilometres of clear weather range. Yeah. So when you look at the economics of 5G, I think it's really interesting to look at ultra-sparse networks as being a really important part of the offer.
Just to comment on the military side, if you go back in time, a lot of the military technologies led to the cellular technologies. I'm that old that we were working on both at the same time. But what's been interesting in the last year, we've been working with DSTL. When I say we, that was when I was previously in the KTN. And they're very much looking at how they fund R&D to actually fund some what I'd call commercial things for things like 5G, so they can leverage it back. So it's reversed. So they are definitely open to discussion and opportunities.
I think it's going full circle. So we're running slightly behind, and maybe there is time for a couple of questions for the panelists. Okay. Okay.
What do you think the 5G technology catalytic elements are going to be to address the social, business, and economic sides of the inclusion? So, what is 5G going to deliver, both socially, economic, and business, that 4G or 3G didn't deliver?
I'm hoping that 5G digital fabric, I use the healthcare example there, you will see on that example it's got utilities, energy usage, it's got hospitals, it's got ambulances, it's got clubs. At the moment, the only thing that really connects them up is the individual, or if somebody's got a long-term condition, their family, friends and carers. There's some lovely apps coming out and things like that, and they're really good, but if you really want to leverage that, connecting across those boundaries, I think will be a fundamental difference, which something like 5G fabric could do.
And what do you think the political blockers or hurdles you're going to have to get across to be able to do that?
We are working on those. So there is a recognition that we need to cross boundaries within government and look at value. On that diagram that I showed you there, for instance, social care is a completely different department from healthcare. One benefits the other. Just recently, you've got the Digital Economy Unit set up, crossing DCMS and BIS. And actually, within BIS now, using the healthcare example, there's a joint department between BIS and the Department of Health. So they're getting the message, but we have to do much more.
Thank you, Stuart. One more question?
Yeah, I think we've heard a lot already about what we think 5G will be, whether it's speed improvements, greater capacity, lower cost, and so on. What does the panel think will be the likely compromise? You can't have all of those. Which factor is it that's going to not live up to?
Do you want me to?
Yeah, well, yes, a quick answer on compromise.
If you look at the context, so if you look at the different, I mean, Geoff's mentioned all sorts of frequency bands. I believe it will be a kind of fabric of different networks and services. So if you can't work out how you interface with those, just take a simple analogy of, when you walk into an area like this, you probably connect to Wi-Fi. We're just getting that, but actually we want more than just Wi-Fi seamlessly. So all of those areas, if you really want to push the best throughput, you can sacrifice latency. If you want to push, broadcast, satellite's great for broadcast, really bad for latency. But do you know what? Sometimes you don't need it. So working out what you need in the best context will be, is it a compromise or an opportunity? I think it's actually an opportunity. But if you try and do one size fits all, then you will compromise.
I'd like to ask Geoff now that the mother of all compromises is cost, right? You argue for cost. What would you give up on cost?
What would you don't need to give anything up on cost if you've got a mutual interest model where you can amortize your R&D over a bigger market, and you can resource R&D from multiple sectors. So, you take the automotive sector. Volkswagen's got an R&D budget, annual budget of $12 billion. You're in the same kind of ballpark as Intel or.
But what about the deployment? I don't mean the cost of R&D. The cost of deployment.
Deployment, I think, is all about getting an elegant mix between dense networks and sparse networks, and actually pushing the sparse network offer in a way that actually transforms the delivery economics. So I don't actually think you need to take a compromise necessarily. I think there's a clear route open to delivering capacity gain from large sites, which also solves a lot of the rural access problems and all the sort of political issues of covering bits that we're covering. I mean, like the latest fuss about rural coverage in the UK. I mean, that's very typical of a problem that needs to be solved, and ultra-sparse networks are one way of doing that.
One final comment.
One final comment on.
Maybe we'll get one.
Well,
Alex,
while you're
how are we
picking
doing with
somebody,
time?
one final comment on
We are running
value.
behind.
Actually, get
Very
people
late.
to understand the value between different technologies, consumer units, and networks is really important. I think Luke's over there with Vodafone. We wrote a paper about 2 or 3 years ago, and a radio, for example, 1 dB loss on the radio meant that they had to spend 14% more on their infrastructure.
This is a
which
great
is
conversation
incredible.
for the coffee break. Just one final question, one very final question with a quick answer, please.
It could be long, but I'll try and reduce it to a yes or no. Do you think that we need a completely new intellectual property regime globally? And is that achievable? Would it delay the whole implications on
That's-
it? Very quickly.
that's
No,
quite
Personally, I think it's
That's
impossible.
quite a question.
I agree. I tend to agree.
But then you can look at something like GNU Radio, which is powering a lot of these 5G experiments right now, and that's a different take on it, because that's a community of people who come together and say, let's do this.
Indeed, maybe the way to answer that is that since the last big revolution on communication, which you could argue 2G, 3G, the world has changed completely. Everybody expects there's open source movement and open innovation and so on. So the world has changed. What are the implications on the intellectual property coming out of your center and so on? That's a big...
So I don't think the world has changed. I think the world has changed from layer 3 up.
Okay.
I don't think it's any different from layer 3 down.
But there could be some market-driven, as you said, as the landscape changes, there may be...
Who knows?
Some larger players may get together. It may be in their interest to change the regime.
Who knows?
But I'm scared.
So layer 3 above is new. Layer 3 and
Well, I
below
think,
is-
I mean, look what's going on with 5G now. I mean, air interface discussion, that's a big IPR play. And that hasn't changed, and I don't think it will.
Thank you. I'd like to thank you all the panelists, and thank you for the questions. And now it's coffee time. And we're running 10 minutes late, Alex? 30? Well, we started.
But we're on time, Maurizio.
We are on time given the start time.
Yeah.